Okay, let's see. Y'all are making the okay, very much populating the chat. Let's see what y'all say. We got watching YouTube. We have listening to movies. Oops, listening to movies and music. Listening to music and play some games. Listen to music, especially Hamilton, and sing along. We got blasting music. Okay, music is a reoccurring theme here. Watching shows. We got more listening to music and drawing. Oh yeah, some of you make some TikToks or do my hair or hi, sorry, do my hi. Watch TV shows. Oh, okay, it was good. Leave my room. That's good. Yeah, like when everyone's gone, you could leave your room. Awesome. We got music and YouTube. Okay, I think I resonate with that. Well, for me, like I do listen to music when people are around, but obviously it's like maybe with earphones. But when people are gone, that's when I like have it out loud, like kind of on speaker on my phone. I like to do that, and I also like to watch stuff like anime. If people aren't that much into whatever show I'm watching, I definitely like to just watch it on my own and just kind of have my me time. Those are at the top of my mind, but basically everything else, um, y'all are saying, I agree. I definitely like to do those things alone. All right, we got watching YouTube. If you just came in, go ahead and answer this question, especially so I could mark you as here. Then we have what genre? Oh my gosh, like what would you call it? I know there's a specific word, but it's like I like girly ones. I know I mentioned what are they called? I think they're called shouju. Shouju type. Make that right. Hold on a sec. Yeah, shoujo anime is the one I like. So it's the girly type. I always like the female leads, and they're like powerful. They have superpowers or something like that, like Sailor Moon, or there's other ones. Yes, thank you, shoujo. Yes. All right, we got. I like to watch movies on any app. We got more listening to music. Awesome. Okay, drawing or art. Yeah, when I was younger, I used to do cartoons, so I used to love doing that. When I was home. All right, y'all. Let's see who I have here. I was too into reading all the responses. I'm just right now making sure I'm marking everyone. Okay, please correct me if I'm wrong. But here's who I'm missing. I am missing Tyree Dennis, Alicia, and Marco. So again, please correct me if you're actually here. Let me know. So that is Tyree, Dennis, Alicia, and Marco. But if you're here, thank you so much for being here. And thank you so much for sharing the stuff you do when you're alone. I appreciate it. Okay, sure. Yeah, if you have to leave to join on your laptop, okay, that's awesome. I'll wait for you. All right, cool. So let's jump into our agenda here today, everyone. So, as you know, the other day we had started at Desmos, but we didn't 100% complete it. So, what we're going to be doing today is we're going to finish that individual Desmos on what is a radian. So that's what we're going to do. After that, we're going to transition into learning a little bit more about what the unit circle is. Even though when we're learning about radians, we are kind of learning about a component of the unit circle. Like the radians are part of it, they're written on there. So, I mean, it's all going to transition us into just in general learning about the unit circle. We'll have an exit question and asynchronous number 8 is actually going to be due Friday. So I posted it, I believe, just yesterday, and this one is going to be due on Friday at midnight. Let me know if anyone has any questions about this or anything that you have in mind. Okay, so before we jump back into our Desmos, everyone, I was going to kind of synthesize some of the big ideas first. So I want to synthesize, and then we're going to go back and get some practice on the skill that's supposed to come out of it. So right now, everyone, I am going to go on slide number 4 to kind of review with you the learning target that was from the other day. And again, make sure you are opening up your own copy of the slides so you could kind of annotate or anything like that. Um, we are going to come back to the slides because there's a second portion on it. But the learning target from the other day, and it's still going to continue on today, is I can explain what a radian is and relate a radian to degrees. So that was a learning target. And I'm going to synthesize right now what were their big findings, the big ideas from last time. Remember, we're trying to kind of really deeply understand what is a radian, how does it come, where does it come from, how do you create one? And the best way I like to think of it is using this image. A radian is when you create an arc length that has length r, which is your radius of your circle. So that's basically what we did. But just to better synthesize it in formal language, it's down here. So it's on your slide. So a radian is a unit of measure for angles. So it's another way to measure angles. And it's based on the radius of the circle. If we imagine, the same thing, we imagine we take that length of the radius, wrap it around the circle, and the angle that's formed at the center of the circle by this arc, we define that as 1 radian. So that was a huge thing that we constructed. So this angle measure is called 1 radian. That was like how we created that definition there. So whenever you have r like that in an arc length, that is defined, that angle measure is called 1 radian. Again, let me know if anyone has questions about this, but this is again synthesizing the big ideas that were coming up in that Desmos lesson that we did together. Okay, cool. Next portion. It wasn't just that. We defined a radian and then we were trying to construct some equivalency from it. So let me remind you. It's going to lead us to a formula for conversion, basically. First things first, the huge important idea was that 360 degrees is actually equivalent to 2 pi radians. How we found that out? If you remember on the Desmos activity, we imagined how many radiuses cover the circumference of the circle. The answer was about 6.28. 6.28 is equivalent about to 2 pi. So that's where that came from. So 360 degrees is equivalent to 2 pi radians. We took this equivalency and we created an equation. 2 pi radians equals 360. Now, some of you in the checkout were saying, well, why is it 360? I mean, why is it 180? Why are we doing pi over 180 instead of divided by 260? Because first off, this formula is nicer, right? It's shorter. And for this one, why? It's because what we did is we divided both sides by 2 to get this nice and simpler formula. So this divided by 2, you just get pi radians. And then 360 divided by 2, you get 180. So this is a shorter, nicer formula to use when we convert. And that's why we're either using pi over 180 or we're going to use 180 over pi to kind of convert between our units. So that is kind of addressing a question that came up and also kind of refreshing everyone on what we did. And yes, thank you, Janet. So because it's 1, I love it. Yes, love that. And then I also found this here image helpful that I'm also going to add because I'm still creating our big ideas packet. I'm going to make sure I add this on our big ideas packet. And actually, this is a nice diagram because it kind of shows you which one of these to use. So if I want to go from radians to degrees, let's say I want to convert from radian to degree, the one that you're going to multiply by is the 180 divided by pi. If you want to go from degree to radian, see the arrow? If you want to go from degree to radian, you're going to multiply by pi over 180. So that's like a little nice chart for you if you need some extra support to decide on what to multiply by. But ultimately, what it ends up being is that you're going to multiply by whatever you need to cancel out. That's how it kind of works out. But here's a diagram if you need some support on that. So I really like it. Okay, now let's synthesize all these visuals into some big idea chunks. So again, the big idea is 2 pi radians was equal to 360. And from that, we got this simplified equality formula. And down here, you convert radians to degrees by multiplying by 180 over pi. And you convert degrees to radians by multiplying your expression by pi over 180. So these right here are the skill. So we just went from a concept, like what is a radian? We created like kind of like an equality or a formula to use to kind of convert between the units, because you can use either radians or degrees to talk about an angle. So we're going to talk today about how to actually do those conversions. Let me know if anyone has questions on that. Okay, lovely. And if questions come up, just let me know. I'm happy to, always go back. Okay. And the last thing that we did when we last met is I showed you a video where I was converting, I did 2 examples. The first example, I converted 60 degrees into radians, and I took a screenshot of that example. So right here, things had canceled out. If you remember the video, I canceled out these degree symbols. I canceled out the 0 because I was already kind of dividing by 10, or kind of taking away that multiple of 10, top and bottom. And then I just got 6 pi right here. And then we're left over with 18 radians. And then what I had to do is 6 pi over 18, I reduced it to pi over 3 radians. So that's how I converted 60 degrees into radians. Let me pause. So let's see, because I know there's like a majority said there was no questions, but is there any questions on this example? I know I just verbally went through it right now, but I could also slow down and specify stuff if we need to before we jump into that practice today.
I have a question.
Yes, go ahead.
So, okay, so I was going through the Khan Academy and it had gave me an example like it gave me 3 pi over 5. I didn't know how to reduce that. Like I was confused.
3 pi over 5. And were you asked to convert that
Convert
to
it
a degree?
to degrees, I think. Yeah.
Okay, so 3 pi over 5. Let's do it. Okay, so 3 pi over 5. So let's try to convert that to degrees. Now, here are the 2 different things we can use. Now, because I kind of want to get rid of the radians, and this is a radian. Whenever you see the pi symbol, that's going to be radians. I'll just call it rad. Whenever you want to get rid of the radians, you're going to use the multiplier that has the radians in the denominator position. So I'm going to use that one. And yeah, oh my gosh, I know y'all, Khan Academy is going to be it's going to be picky on how you're simplifying. So, but I do encourage you to click the get the hint button, and they kind of
I
show
did.
you.
I did, and it was like it didn't really give me like a
Like,
full like explanation.
okay, okay, I got you, I got you. All right, let's go ahead and talk about it then. So I thank you so much for bringing this problem up. That way we kind of get some more exposure, because actually one thing someone else said was we need more examples. So I love it. Okay, let's see. Let's look at this. So what cancels out so far?
The radius,
Yes, perfect. What else can cancel out?
degrees,
So here's a degree symbol, right? But then I don't see no other degree symbol. So what's something else that's kind of the same, but there's
Pi.
who said what was that?
Pi.
Pi? Okay, so Francisco, you're saying pi. And
Yeah.
by the way, the female that was talking, I don't recognize voice as well, but who was talking right now? The original talker.
Jenny.
Yeah. Okay, it usually shows me the name, but it's okay. Thank you, Janet. Okay, so do you see, Janet, why it would be pi? Because we have a pi up here and we have a pi down here.
Yeah.
So
I
when it,
thought I thought we weren't gonna be able to like cancel it out because it was a 3 and the other one doesn't have a 3. So I was
that's a good thing to point out. So actually, yes, you can still cancel it out for sure. Yeah, because I could see what you mean. because let's see, like in example two, right? You don't see that there's a number in front of this pi when I canceled out. Is that right?
Yeah.
That makes complete sense. So I love that you brought this example up, but we could still do it. So boom and boom. So now what we have is basically all we're left over with is 3 times 180 degrees. And y'all let me know what that is. What's 3 times 180? You use a phone or something. It's really hard to tell quickly. 3 times 180.
540.
540. And and then there's probably some in the chat. Y'all probably said 540. And then because we did not cancel out degrees, you're still left over with degree symbol. And then we still have something in the denominator position. That means we're still dividing.
Let's divide
And
by 5.
perfect.
Yeah, 108.
108.
Yeah.
There we go. So that would be how, for that particular Khan Academy example, how you would simplify that into degrees. Lovely. Thank you so much for asking this. And let's see what's in the chat. Okay, perfect. So we got the pi and we got the answer of 540 when we multiply 3 times 180. I love that you already asked this because we're going to get some practice right now. So people might come up with some more questions. All right, yay. It's great that that made sense. Okay, perfect. And that was an example, something like example two for everyone else who was taking a look here. It's kind of like we did. So that's when you're converting radians to degrees. That is another type of way, another example that we could do this process. So if you look down here as well. Let me know if there's any last burning questions before we jump back into that Desmos. And we're all going to actually do some practice and take a look at how we're doing this. All right, let's go ahead and head over. Let me clear my screen. And let's jump back into Desmos. I'll give you all a minute. We are period one. So let's log into the period one once more. You should log into where you left off. So as long as, of course, as long as you're logged into your school Gmail and whatnot, it should put you back to where we were. So here's you go. So you go to student.desmos.com and then you go ahead and you put in this code. So let me give you all a minute. All right, everybody, welcome back. I'm gonna go ahead and join you all on Desmos together. So let's see. Okay, we have, so as you can see here, little boxes highlighted means you're in. If your box is not highlighted, that means we're missing you. So make sure your little box gets highlighted there. So we're still missing a few folks. Go ahead and check out my screen. I'm gonna also just go ahead and put the link into the chat just to make sure we get everybody. Definitely want to make sure that you complete this for credit. If by the way, if anyone's curious, sorry, let me anonymize this first, but um, if your boxes look like this, that means you're still missing your responses. So just in case, if you're like, I was doing the Desmos, just make sure you go back and fill in your responses. At the end of this, don't worry, the whole Desmos will open up, so you'll be able to make up anything if you need to. But awesome. So it looks like we have, let me just name who we have. We have Francisco, we have Juliana, Marjorie, we have Henry, Aisha, Kimberly, Rogelia, Janet. I think we're still waiting for you, Miles. We got Leslie, Dana, Jorge. Who else we got? Kayla, Gianni, Marvin, and Niara. And then we're still missing a few folks. So go ahead and join us, please. Let's have a few more seconds. All right, awesome. Let's go ahead and get started. So what I did right now, you should be able to see slides 10 and 11. So on slide number 10 is basically, let me go to student mode. So slide number 10 is basically, you could go back and review that example I did the other day. It's about a 4-minute video. You could, skip through it and all that. You could also go back to see what questions were coming up for you. But for the rest of us, if you're ready, you could go ahead and try out this one here. And then try to show your work in steps, even though I know that could be a challenge on Desmos, but it'll help us see kind of like what are you doing to kind of convert. So everyone, let's go ahead and try to convert 80 degrees into radians. And we are on slide number 11 for sure. So some of you need to switch to computer, no problem. All right, so I'm gonna go ahead and give you all some time. Let me just make sure that everyone's good. Okay, great. I already see some work getting started on here. Perfect. And if you're stuck, feel free to check out my screen. How about that? So I'm gonna leave this screen kind of here. Oops, I'm gonna anonymize everyone. And let's go ahead and have about, uh, a minute or two. I'm gonna see how much more of us still need some time. I'm definitely going to give a little bit more time. I love that a lot of us are taking the time to write out their kind of step-by-step process. So I'm going to give us some more time and also switch to a student mode. So I could see if there's a different kinds of answers coming up. I want to definitely take a look at those. So I'm going to switch back to student mode. So this is what you see on my screen. Let's take one more minute. All right. Okay, I'm excited to see what y'all have. Okay, let's see. So I okay, converting degrees into radians. So what I'm when I'm looking at this, I'm trying to see like what is the setup. I see pi over 180, pi over 180. Ooh, someone knows how to use their fractions here. This is Candace. We got pi over 180. So I'm just trying to see if everyone's in agreement on what we do need to multiply by. Here we see 80 over pi. There's a difference here, a difference there. Pi over 180, pi over 180. I love that this is a verbal explanation. Like instead of like actually typing out the steps, there's like a verbal explanation. Ooh, I love that. I'll read that in a sec. We got pi over 180. Okay, so a lot of us are agreeing on the first thing is we're going to multiply by pi over 180. And I think Albert Einstein, you put 80 times pi. So I don't know if that was actually you multiplying or if there was confusion on which one to use. But for this one, yes, we're going to multiply by pi over 180. And I want to look at that verbal description. I like this. So Dorothy says first it would be 80 degrees times pi over 180 degrees. Then it would be 8 pi over 18 because that's what leads to radians. So 8 pi over 18. So it looks like they cancel out those zeros, kind of like that strategy I did in that video to get 8 and then over 18, and then not forgetting that there's a pi on top. And then finally, you add 2 divided by 2 because you're going to divide what you have, which finally gives you 4 pi over 9. So basically 8 pi over 18, they divided 8 by 2 to get 4. They divided 18 by 2 to get 9. So there's a verbal description for those who needs like the steps. That's awesome. And then we have a beautifully nice blaze right here set up like if you're more like to see the symbolic representation of the steps rather than a verbal explanation, here we have it. So this is the same thing that Dorothy did down there and verbally explained. And yeah, I think our answer is going to be 4 pi over 9 radians. Um, this person got 1.39 Emmy. And I mean, it could be, I mean, if you just converted all of this into decimals and then divided, it could be, but I'm not 100% too certain. I could check. Let's see. I'm gonna use my calculator. What was that?
So are we supposed to just simplify until we can't?
Yeah, you just keep simplifying until there's nothing else more that you can cancel out. So
Oh,
actually, I just checked Emmy. So Emmy, this 1.39 is actually equivalent to 4 pi over 9. If you were to do 4 times pi divided by 9, you do get 1.39. So Emmy, you're not wrong. You definitely do want to try to push yourself to kind of simplify in this manner because you know in the unit circle they don't include the radians and decimals, but you're not wrong. So that's for Emmy, just so you know. That's awesome. I just checked it on my phone too. Awesome, awesome. So let's see. Other than that, does anyone have any questions on this? So yeah, the answer is 4 pi over 9. And if you look at the screen, there's a variety of different explanations that kind of could help you see how everyone got that answer. And I also noted that 1.39 is equivalent to the fraction representation of 4 pi over 9. Okay, we got here 1.40 rad. Oh, round it up. Oh, look at that, y'all, Alicia. So converting to the decimal representation of the radians, it's still equivalent, so you're not wrong. I just love that that's coming up because it's showing that you're not, following the exact process that I'm doing. You're using it the way that you understand it. So awesome. All right, let's see. Are there any questions coming up for anyone up at this point? Any questions, clarifications, or if you want me to check out your answer, feel free to let me know in a private chat. I'm happy to do so. Okay, y'all are marvelous. Let's go ahead and do one more practice. Of course, you're going to have your Khan Academy to practice a little bit more. And then feel free to, jump into office hours if you need some support. Let's go on to slide 12. So I'm just going to click on the plus. There we go. Let's all move on to slide 12. Slide 12 now is asking you to convert radians into degrees. So I'm going to go ahead and give about a minute. I'm going to switch to student mode because I want to see the variety of answers and the independent thinking that's coming up. Like you know how every answer wasn't the same in the last slide? That's like brilliant right there. That shows independent thought. Hi everybody, I am back taking a look at our student work. So let's see. Okay, so I see Jean here is multiplying the 2 pi over 3 by pi over 180 right here. Then they're noting that pi cancels out and then they got 0.66. Okay, then Albert here is multiplying by 180 over pi. So there's like a different, the orientation, a little bit different. But they get the same answer. So interesting. So then continue to multiply. Okay, so this turned out to 2 over 3, but then they multiply by 180. So I guess my feedback would be this one here. You still ended up getting the same answer, which probably, and this is for Gene, maybe you figured it out, but definitely the first thing you want to start off with is for this one to convert radians into degrees, you want to make sure your radians cancels. So for this one, you want to make sure pi radians is in the denominator position. That way you could clearly see this, cancel, cancel. And then if you were to write rad here, the radians would also cancel. And you'd be just 2 times 180, then divided by 3 to get your answer of the 120 degrees. But you still got the same answer. So that's just feedback just in case if there was any confusion on what to multiply by. Awesome. Let me know if anyone has questions about what I just said here when I was kind of comparing Jean's work and Albert's work. Awesome. All right, let me go ahead and clear my screen and then let's just see what else is happening. Definitely just want to see if there's anything else other than multiplying by something different or anything like that. All right. I'm seeing a commonality of 120. I see that Joseph started writing out 2 pi over 3. And then if you're stuck, Joseph, just take a look at my screen to see what people are doing, or you could refer back to when I gave Jean and Albert some feedback. Here we got that verbal explanation. Pi cancels out, so you get 2/3 times 180. Basically, that's 2 times 180, and then you divide it by 3 to get 120. Awesome. You know, there's a question mark, like 120? Yeah, you got it, 120. Not too sure? That's okay, Albert. Just take a look at what the variety of ways people are writing this down. Check out the screen. Do let me know if you have questions. All right, look at that, Dorothy, in the verbal explanation. Awesome. Okay, so I don't see anything different coming up. But again, if you're stuck, take a look at my screen. I'm also happy to take screenshots of this and stick them in my slides so you have more kind of examples as well to look at. But awesome. So great. The last slide is basically just answers. So you can also use that. I think I do have this part of my slide. So the last screen, so screen number 13 is our answers. So yes, for the first one, we get 4 pi over 9. Some of you converted that to decimal format, which was still correct. And the second one, we do get 120. So again, any last burning questions for how we got these? If not, we're going to transition us back to our slides, and that will conclude the Desmos. Let's see. Yes. And now I'm able to use that pi symbol, so I'm able to utilize that, Francisco. Yes. And I know a few more were able to use it, so that's great. All right, everyone, it seems like there's no burning questions. So I'm gonna go ahead and stop the pacing on this. So that means it's all open. So if you need to go back and make sure you fill out answers or anything so that I could give you credit, go ahead and do that. Do let me know in an email though, that will help me out too, if you want me to check. Okay, let us go back to our slides, y'all. So I hope you have your slides open. I see a few of us on there. We're gonna be going to slide number 9 to talk about the unit circle. And that's gonna like transition us into the last day. So it's not too heavy. It's gonna be a little introduction to what is unit circle, how does it work, all of that. And our learning target, as we transition out of talking about radians, is I can explain the components of the unit circle. Okay, and I just want to make sure I give time for everyone to just go to their slide, open up. We're on slide number 9, and now I'm heading to slide 10. Let's see what's in the chat. Wait, I need the code one more time. The Desmos code? There you go. Got you. Yeah, check. Let me know if that works. It should work. Okay, everyone. So as you know, in this Desmos, I did show you the fully complete unit circle. We actually now finally actually now understand these red ones here. These red angle measures are radian measures. Y'all, if you were to actually sit down and convert each of these degree measures, let me see, like for example, like let's say you took the time, okay, I'm gonna convert 360 degrees to radians. You're gonna get 2 pi as your radians. I'm gonna convert 330 degrees into radians. You're gonna get 11 pi over 6. So we now kind of get where these red parts are coming from, these red radian fractions. That is what we just learned. So like I said, you could verify this yourself and do the calculations, but that's what they are. So that's great. We kind of already got one component of the unit circle taken care of. Now let's talk about how this works. How do we use it? How do we measure on it? First things first, this is how we usually are going to measure angles on the unit circle. So you kind of have to imagine that you have like a ray that's on the positive x-axis here. So this is the positive x-axis. We call this the initial side. And it kind of opens up to create an angle. See, it's opening up to create an angle. This side right here is called, or this ray right here is called your terminal side. And it measures angles around the unit circle. Now the terminal side moves around its vertex to create these angles. So let me show you. Let me use like a straight thing. So let's say if I want to create a 30-degree angle, so I'm going to draw my initial side right here that's flat. And then I'm going to imagine that I lift up the terminal side to make a 30-degree angle. I'm going to lift it up to here. That is where the 30-degree point is at. Boom. So that is my terminal side. This is my initial side, and that's the 30-degree angle, which is equivalent to pi over 6 radians. That's how I would kind of create the angles on a unit circle. What is this? It's like a cheat sheet. Yeah, it's kind of like a cheat sheet. Yeah, to be honest, except, oh my goodness, when I was in high school, we had to memorize the unit circle. I'm not going to have y'all do that. I mean, I probably would have done that for maybe extra credit, but there was like different techniques to memorize it. Like you had to memorize all the radians, and all the coordinates too. But I remember it didn't make sense to me. Like, I don't understand like where all of this is coming from. I didn't learn what a radian was. I just knew I had to memorize it, and it was part of the unit circle. But now at least you all know what a radian is though. So that's good. And then Ms. Lister forgot what the y-axis is. Hey, that's okay. That happens summertime. Summertime, I forget all my math, so no problem. Okay, so that is kind of how you draw an angle on the unit circle. Again, I like to use this. That's exactly what you're doing, but you're doing it within the unit circle. So initial side is on the positive x-axis. The terminal side is the ray. So you call this like a line that has a little arrow on it. You call that a ray. It's just a definition. Is the ray that rotates about its vertex right here to measure the angles on the unit circle. So you just could open it and rotate it around to measure angles. And someone mentioned this on the Desmos, which was cool. They were saying that the angles on the unit circle were were kind of growing counterclockwise. That's exactly correct. That is part of the definition of what is a unit circle. How we create angles, positive ones, is we move the terminal side counterclockwise. So that means, you know how the clock usually moves this way? Like if you're looking at a clock, even though clocks are now getting outdated for phone clocks, but usually clocks move this way, the hands move this way, but counterclockwise means you're moving kind of opposite of how a clock moves. So you move counterclockwise to measure positive angles. And well, then what happens if you were to move clockwise? What if you were to move in the opposite direction, like a clock? You actually move the terminal side clockwise to create negative angles, everyone. So you can create negative angles on the unit circle. So that was, if I was to do this and move backwards clockwise, this would be a negative angle. And we could just say, I don't know, negative 35 degrees or something. And then you could convert that to radians, to whatever that is. You would do it the same way, except just make your radian negative. So that's just how you would create negative angles. You move down backwards. Let's see if anyone has any clarifying questions about any of this so far. Here's are just the bullet points of things I was explaining verbally and also kind of drawing on there. Okay. So then these are the different kinds of angles you could draw on the unit circle. And notice how here's a negative angle. And again, this is like just imagine let's see if I could create a circle. Let's imagine this is on the unit circle. There we go. Cool. Let's just imagine that. These were the only like angle measure pictures I was able to find that kind of best describes it. But just see, I'm just adding a circle there so you could envision that this is on a unit circle. And they should be all the same size. I just, just quickly made a circle. But So if I'm on the unit circle and I want to create a negative 60-degree angle, I just move I just move clockwise, and that's negative 60. If I want to create a positive angle like 135 degrees, you just move counterclockwise. What if I want to keep going around and around? You can do that, y'all. Do you know you could create angles that are larger than 360? You go around once, right? That's 360 degrees. You go around another additional, I don't know how much, and then you're at 570. You could keep going around and around on the unit circle and make larger and larger positive or negative angles, actually. So take a look at that. That's cool. And here's another example of a negative motion. So this was moving negative 270 degrees. So it kind of looks like a right angle right here. Um, so why do we have to move backwards, or why sometimes do we have to have larger than 360 degrees? Well, the reasoning is right over here. So there's applications such as rotating wheels, where it's convenient to expand our definition of an angle. So measures can be any number of degrees, including positive and negative values, because we could kind of better apply it in the real world and create functions that represent repetitive motion. So that's why it could go more than just once around the unit circle. Let's see, does anyone have questions on this portion? Okay, I hope silence means we got this, not confusion. But hey, if you're confused, I am here for you, office hours, and or you could just ask, and I could stop the instruction and help us out. Okay, so then, um, mm, now we're not going to do that. We're going to look at this together and do the checkout together. So ignore this 2-minute timer. I was actually going to have y'all independently kind of explore this for 2 minutes, but due to time, let's look at it together. And then that's going to be our checkout. Okay, so what we're going to look at together is we're trying to ask ourselves this question. So, okay, cool. We talked about the unit circle. We talked about what radians are, but how does trigonometry, remember what trigonometry was? Remember those definitions? How does that show up on the unit circle? So I wanted y'all to kind of explore this using this tool, and we're going to add our thoughts on a Padlet. So let me explain this tool. This A right here is degrees. So if I want to go back to 0 degrees right here, I'm flat. I'm on the positive x-axis. And let's say I want to create the terminal side to be 1 degree. That's 1 degree. Let's say I want to do 30 degrees. So see how the terminal side is moving up, and I am creating a 30-degree angle. So this is all in degrees. It doesn't have radians. That's okay. Of course, like I said, if you want to add your radians, you just convert all of those degrees to radians and you'll get your radians. So just take a look at how right now, think about how is trigonometry related to the unit circle? And you're going to answer that right now in a Padlet. So hold on to your thoughts. Let's just look at this. And I'm just going to keep increasing my angle. Let's see what happens at 90 degrees. That's what 90 degrees look like. Looks like a flat line. Oh, okay. So this is what happens if I move on the other side. Interesting. I'm at 120-degree angle, 150, and 180. Then I just keep going. So again, I'm just increasing my angle measure. I'm at 210 degrees, 240, 270. And then we're going to 300 degrees. We're at 330. And then we're going to make a full 360. Now this tool doesn't do more than 360, but just fully understand that you can do more and more rotations and go above 360 degrees. But I just kind of demonstrated to you a tool that perhaps is getting you to think about how is trigonometry related to the unit circle. So now, hopefully you had some thoughts on that. And we're going to go on the Padlet and put down our thoughts. And that's going to lead us into how exactly is it connected into our next week's lesson. So let me go ahead and get you all the link. If you're with me, it's slide number 13. We are period 1, and this is going to be our checkout. So again, how does trigonometry, or how do you think trigonometry is showing up on the unit circle? Put the palette in the chat. And we are on column number 5. Let me double check that. It's loading for me. Oh yeah, there we go. Yes. So we are on column number 5, and I also attached the tool here so you could play around with it. So remember, you just move it around and it moves the terminal side for you for how many degrees you want. So again, what are your thoughts? How does trigonometry show up in the unit circle? We are on column number 5 on the Padlet. I'm going to put the directions in the chat, give you some time to put your thoughts. Don't forget your name or initials here. All right, I know some of you are finishing up your thoughts there, but let me just go ahead and highlight some things that are showing up. So using that tool, a lot of you are mentioning that there's degrees, radians, and right triangles that are coming up. And to remind you, trigonometry is the study of triangles and how triangles show up like basically everywhere. And there's measurements, the angles, radians. There is all forms of triangles within the unit circle, I'm noticing. We have the degrees that are showing up. I like this one here. Look at this. I like it just because it's mentioning something about a hypotenuse. Like, let's see what this is Henry's answer. So trigonometry shows up in the unit circle with the longest side, the hypotenuse of the triangle being the radius of the circle. That's deep. So that's deep. Um, that's interesting. That's actually getting even me to think about this a little deeper too. Um, again, some of you are noticing those right angles. All of you are right here, degrees, radius, angles, love it. And you're seeing that there's right triangles popping up. I also see that pi is mentioned, right triangles. Yes. So a lot of you are kind of seeing those right triangles. Perfect. So yes, that's going to lead us into our next thing. We can build right triangles inside the unit circle. And that's how trigonometry is connected to the unit circle. So we're going to investigate this further next week. But until then, y'all, thank you so much for your amazing thoughts and ideas. All of them are amazing. So I appreciate y'all. All right. Enjoy your day, everyone. Bye. Thank you. Bye, everyone. Have lots of fun. Bye.